Hello, hello, hello. I am Axel Cannon, and this is Stupid Game Experiments. My current stupid experiment is building the same game in three of the most popular game engines, Unity, Unreal, and Godot. The game is called SH++, and it's a cross between N++ and Asteroid. And this is my 6th weekly recap covering all the development that's happened in the last week. This week, I'm going to be focusing solely on the map builder for the game because it's what I spent most of the week working on, and I think it highlights some interesting differences between the three game engines. My goal for the game is to eventually make it so that the details for individual maps can be saved as text files to make them quickly transmittable online. This is in anticipation for eventually allowing user-created levels. The goal for my map builder then is to read these text files and turn them into the map for the level. I'm nowhere near accomplishing that yet, but the work I've done so far is built with that in mind. So far, my map builder only deals with the walls for the map, but eventually it will be expanded to include all the enemies and obstacles as well. The walls for the map are made out of two different shapes, a square and a triangle. Both of these shapes can be scaled on their X and Y axis. For the triangle, this allows for walls that can have sharper angles than the default 45 degrees. Finally, the triangle walls can also be rotated at 90-degree intervals so the angle faces different directions. My first attempt at building a map builder was done in Unreal Engine. However, for this video, I'm going to start by talking about the Godot and Unity versions because they're both similar to each other and a lot less complicated. The Unreal Engine version is a completely different system, so I'll talk about that one separately. For Godot and Unity, the map builder is divided into two different portions. In Godot, the first portion is the wall cube scene. This is the building block of the map. It's called wall cube because I originally thought I was going to make separate scenes for the triangle and square map pieces. However, as I was making it, I realized that I could do both in the same scene, no problem. The second portion is the map builder scene. The map builder takes a list of block attributes and adds the necessary instances of the wall cubes with those attributes to the level. In the wall cube scene script, specific variables have setter and getter functions attached to them. The getter functions just return the values. However, the setter functions handle updating the various components. For example, the isSquare boolean switches between the square and triangle shapes. It does this by updating the sprite image and the polygon shape of the collision. The position and the scale of the wall cube is set on the topmost wall cube node. However, the pivot node was added below this to handle the rotation. This ensures that the position and scale of the wall cube produces consistent results. Otherwise, the wall cube's position and direction of scaling would change based on its rotation. I have some more thoughts on Godot, but first let me go over Unity since it will help demonstrate the comparison. In Unity, the map builder is actually divided into three prefabs because the wall block had to be divided into two separate prefabs to accomplish the same pivot functionality that was accomplished in a single scene in Godot. The first prefab is the inner wall block and contains the sprite renderer and the polygon collider. The second prefab is the outer wall block and it contains the first prefab as well as the main script for the wall blocks. The first prefab essentially acts as the pivot in Godot, allowing the sprite and the collider to be rotated within the scaling and positioning of the outer prefab. Within the wall block script, I used the same setter and getter setup that I used in Godot to handle the sprite changes, rotation, collision, etc. For Unity, the map builder script is mostly the same as Godot in terms of what it does. It takes a list of block attributes and then adds the blocks to the map. There are a couple of differences, but before I cover those, I owe Godot developers somewhat of an apology. In my video about programming languages last week, I said that GDScript's flexibility meant that it wouldn't throw compile time errors the way other languages do. This would mean that many errors that a compiler would normally catch would be missed, and this would make larger projects harder to manage. I was partially wrong about this. Godot does allow for static typing, which can be used to get the compile errors I was looking for. However, it's not as complete as in other languages. For example, exports only allow for built-in and native variable types, and arrays can't be typecast at all. Also, enums aren't a type as they are in other languages, and structs don't even exist. Ultimately, this is part of my ongoing project to try and figure out how to build the most robust game possible in all three game engines. And it's going to require more investigation on my part to figure out the capabilities and limitations of Godot in this area. The reason I bring this up now is because I used both enums and structs in the Unity version of the map builder. In Godot, I created a couple of enums as well, but enums aren't types. They're just references to integers. So when I passed them through a function, I had to re-verify in the function that they were within the enum range. For the structs, I found a recommendation online to just create a class and use that as a struct. This would probably work. However, I was using the struct to create an array of information about the blocks. Well, arrays aren't typed in Godot, so I wasn't getting the added functionality I was looking for anyway. For now, I'm just using a nested array. I'll probably change it later, but since it didn't really add anything at the moment, I decided to wait until the map builder was more developed. Finally, this brings me to Unreal. For the map builder, Unreal ended up being a completely different beast. The reason for this is that instead of using individual game objects for the wall blocks like I did in Unity and Godot, I used hierarchical instance static meshes instead. An HISM is a collection of meshes that all have the same mesh but have different transforms on them. The advantage of HISMs is that they only do one draw call for for the single mesh they represent. They then just re-instance it as many times as necessary, as opposed to doing one draw call for every single instance. Basically, it massively reduces the rendering computation requirements. Now, does this really matter for a game like this? Probably not, but I just always use HISMs whenever I'm going to put a bunch of the same mesh in a level. In this case, the downside was that I couldn't use the pivot system that I used in Unity and Godot. This meant I had to write all the code to calculate the locations and scale based on the rotations. I'm not going to go through all that code because it's kind of a mess and just a bunch of complicated math. That being said, I could have just done in Unreal the same thing that I did in Unity and Godot. The difference would have been a per frame computation cost as opposed to the initial coding and loading computation cost. Like I said, in this case, it probably didn't matter too much, but using HISMs is just a habit for me at this point, and so that's what I did. For now, that wraps up this week of development for SH++ in Unreal, Unity, and Godot. If you're enjoying these weekly recaps, make sure to let me know by hitting the like button, and if you haven't yet, make sure you subscribe to the channel and turn on notifications so you don't miss out on future updates. If you need to get caught up on previous videos, there's a link to the full playlist in the description below. As always, thanks for watching, and I'll see you next time.